In this lesson, we're going to be talking about one, two, and multi-step inequalities. And the first thing that we need to know are the symbols that we use to represent an inequality. And you can see those four symbols at the top of the page. We have greater than, less than, greater than or equal to, and less than or equal to. And we'll be talking about those symbols as we progress through the lesson today. There is a very, very important rule that we have to remember whenever we are solving inequalities, whether they be one, two, or multi-step. And the rule is this: when you're solving an inequality, multiplying or dividing by a negative number causes you to have to flip the sign over. What I mean by flip is that if the symbol starts as a greater than, you're going to flip it around to a less than symbol, and vice versa. And same thing for greater than or equal to. If you have to flip that sign, you're going to flip it to less than or equal to. So really you can see that these first two symbols that we have over here on the left, these two symbols kind of work together. And the same thing with the two on the right. They kind of work together as well. Another quick little tidbit about inequalities is what these inequality symbols actually mean. And basically, the ones on the left-hand side, so are greater than and less than, they basically mean that the number that you end up with as your answer is not included in the solution to the inequality. And I'll go a little bit more in depth as we move forward. Oftentimes that is represented by a little circle that is open, just like this one. And then the two symbols over on the right-hand side, the ones with the little lines underneath, these represent that a number will be included in the solution to an inequality. And we usually represent that with a closed or filled in circle, just like you see here. Okay, and we'll be talking about those as we progress through. So as we continue on here, don't forget about this rule. Okay, we'll see it quite a few times in this lesson today. All right, before we dive into solving inequalities, I do want to teach you about a new notation that we use to represent an inequality. And we've already learned about set notation. And remember, set notation is just a way that we represent our answer. And that's the same thing that we're doing now with interval notation. We're representing an interval on a number line. So this is kind of a tricky concept. So let's go through a couple examples here, and then I think you'll get the grasp of it. So this is what interval notation will look like. Here you can see I have four graphs of different inequalities. And I'm first going to go ahead and represent what the inequality is that represents this graph. So for this first one in the top left-hand corner, this is going to be represented by x is greater than 5. And here's just a couple little notes to kind of help you know what symbol to use and kind of where to put things. We always put our variable on the left side. So notice how the x is in the far left position. Then the inequality symbol is going to be greater than because it does not include that number 5. Notice how it's an open circle like we talked about above. And here's just a little helpful trick that I always find to be helpful to me. Notice how this is what the symbol looks like, and notice how it looks kind of like an arrow pointing to the right, just like our actual example in the problem. So that's just another way to help you figure out what symbol to use. And then, of course, the number 5 is there because the open circle is on the number 5. So this graph would represent all numbers, which is x, which are greater than 5. So they represent every single number, including integers, including decimals, fractions, that are greater than 5, but not including 5. Okay? So that's what this inequality represents. Now let's talk about how we would represent this answer in interval notation. Here's how we would represent it. I noticed that my arrow begins at 5 and it is not included. I'm going to indicate this by using an open parenthesis. Then I'm going to write 5 because that's where the interval begins. And I'm going to write a comma. And then I can see that my arrow is going in the positive direction. We're going to call this positive infinity. And of course, you would call this direction negative infinity. So it's going to go up to positive infinity. And since positive or negative infinity are not actual numbers on the number line, they're more of a direction or a theory, then we're going to close this with a parenthesis. Okay, so this is how we would indicate this interval in interval notation. Now, I'm going to show you a little bit of contrast over on this, the example over on the right now. So first, let's come up with the inequality. And the inequality is going to be x is greater than or equal to -1. And you can see that because we have a closed circle, which means that that point is included. And where our arrow is going to the right. So we're looking at all numbers that are greater than or equal to that -1. And that would be the inequality that represents this graph. Now, to represent this in interval notation, there's a little bit of a change here. Since that point -1 is included, this is how we represent included. I'm going to use these things called brackets. And then I'm going to write my -1 because -1 is included, comma, and it is going in the positive infinity direction. So I'm going to write positive infinity with a parenthesis. And there you have our interval notation. This is representing the interval that we see below. Okay, let's look at two more, and we'll be practicing this throughout the lesson today. So in this next one, our inequality will be x is less than -3. And again, you can see here, just using that symbol of less than, you can see that it actually kind of looks like an arrow going to the left, which is what we have here. So let that help you with this. And then to represent this in interval notation, we always read it like a book. So if you look at your graph, you can see that the lowest point is -infinity, right? Because remember, the arrow is moving in that direction. So I'm going to begin with a parenthesis and then -infinity, comma, and then it goes all the way up to -3. But -3 is not included, so I'm going to use a parenthesis to represent that. Interval notation sometimes looks like a coordinate, but it is not a coordinate. All right, let's do one more example here. All right, the inequality here is going to be x is less than or equal to -2. That's our inequality. So this graph represents all numbers on the number line that are less than or equal to -2. To represent this using interval notation, you can see that my arrow, again, is moving in that -infinity direction. So my lowest number is going to be -infinity. And I'm going to put a comma there, and it's going to go all the way up to -2. But this time, it's going to be included with a bracket. And there's your interval notation. Now, just remember, just a little note here about the infinity symbols. Now, -infinity is always on the left-hand side, and then positive infinity is always on the right-hand side. Because if you're looking at a number line, that's how it works. So we're always going to have the -infinity on the left, and then the positive infinity on the right-hand side, just like that. All right, now that we understand interval notation, let's go ahead and talk about some of these inequalities. So let's look at the first one. You can see that this is just a one-step inequality. So I'm going to solve this inequality just like I would a regular equation. So I'm going to go ahead and I'm going to add 5 to both sides. Notice how I'm lining everything up very nicely. And my 5s will cancel out, and I'm left with y is less than 1. I didn't have to flip any signs there because I did not multiply or divide by a negative number. So y is less than 1 is my inequality simplified. Now let's go ahead and graph it on the number line. You do not need to represent all of the numbers that you can think of on the number line. These three will suffice. I usually like to put 0 right in the center, and then I'm just going to put a 1. That's my number in my inequality. And then I'm going to choose its additive inverse on the other side. And those three will suffice. Let's go ahead and graph it now. Y is less than 1. So that's going to be an open circle on 1. And I can see that my symbol is kind of an arrow going to the left. So I'm going to represent all of my numbers to the left of -1 and not including that 1. Okay, I'm sorry if I said -1, positive 1. To put this inequality in set notation, it's going to look like this. Squiggly bracket, y such that y is less than 1. Simple as that. Interval notation will look like this. -infinity, comma, 1, parenthesis. And that's it. Let's try another one. All right, in this next one, we have a 2-step this time. So we're just going to have another step that we're going to include. So I'm going to go ahead and I'm going to add 24 to both sides because personally I see those constants and I want to get those together and I want to get the x by itself. So those 24s will cancel out and I'll be left with 18 is greater than -9x. Now, you might want to flip things around to get the x on the other side. Personally, I like to wait till the very end. So let's go ahead and I'm going to divide both sides by -9. By dividing both sides by -9, I have to flip the sign. So watch what I'm going to do. I'm going to flip it. And I wouldn't wait till the end. I would do it immediately so you don't forget. Now we have -2 is less than x. And you cannot graph an inequality until the x is on the left. So at the very end, when you get to this point, go ahead and turn it around. So x is greater than -2. And that is the solution to my inequality. So all of the solutions to this inequality will be all real numbers that represent x that are greater than 2. I'm sorry, -2. So let's go ahead and represent that on a number line. 0, -2, and 2. Those are the only 3 numbers that you need. Then I'm going to have an open circle on -2, and I'm going to go to the right because I'm representing all numbers that are greater than -2. All right, our set notation will be a little squiggly bracket. I'm going to use the variable x such that x is greater than -2. Literally just going to rewrite that inequality. My interval notation will be parentheses, -2, comma, positive infinity, parenthesis. So those were 2 examples of a 1 and a 2-step inequality. And I love kind of learning equalities right after equations because the balancing of the inequality are skills that we have from the last unit. So now we're just adding new concepts to that topic. All right, let's go ahead and bump it up just a little bit now. Let's do some multi-step inequalities. And this is what we're going to be, looking at the most. So let's look at this first one. You can see that I have parentheses in here, meaning that I have to distribute just like I normally would. So let's go ahead and start this problem just like we would if it were an equation. I'm going to go ahead and distribute. So I have -8x minus 12 is less than or equal to -30 minus 2x. Okay, now that I've distributed, I want to combine like terms actually, but I can't combine anything on the left and I can't combine anything on the right. So now I want to balance my inequality. Personally, I always love starting with the variable, so I'm going to add 2x. I'm going to move him over to the left-hand side so that those disappear over on the right. And I'm left with -6x minus 12 is less than or equal to -30. So you're going to notice that it's going to look a lot like an equation. Inequalities and equations are very similar. The difference is equations have one answer and inequalities have many answers. So, but let's keep on solving this like we would if it were an equation. I'm going to add 12 to both sides. okay? And that's going to leave me with negative 6x is less than or equal to negative 18. And the last step is going to be to divide both sides by negative 6. And since I'm dividing by a negative number, meaning that number, negative 6, it's a negative, that means I have to flip the sign. Okay, so this is going to leave me with x is greater than or equal to 3. And that is my inequality simplified. Now let's go ahead and graph it. I'm going to start with my 0. I'm going to put my 3 on my number line, and then I'll go ahead and put my additive inverse, which is basically just the opposite. And x is greater than or equal to 3. Well, I'm going to put a nice closed-in circle. Make sure you fill in your circle completely. And I'm going to be taking my arrow to the right. So the solutions will be all numbers that are greater than or equal to positive 3. My set notation will look like this. X such that x is greater than or equal to 3. And my interval notation will be bracket 3, comma, positive infinity, parenthesis. And there you have it. Okay. Now, let's go ahead and look at a multi-step inequality with fractions. I know this looks intimidating by just the first, look at it, but feel free to use your graphing calculator or Desmos to help you with these fraction operations. So let's first begin by distributing. I'm going to distribute 8/3 into negative 7/2 x, and that's going to leave me with this, negative 28 over 3x. I know it's kind of an ugly fraction, but let's just work with it. And then I'm going to distribute 8/3 into 1. And of course, that's just going to give me positive 8/3. And notice that negative 4/3 x is not in those parentheses. So I'm not distributing anything there. I'm just going to go ahead and tack him on to the end, just like that. And that's going to be less than 40. So distributing is done. Now let's combine like terms. I can combine my x's. And again, this is just a subtraction problem using fractions. This can be done right in the calculator if you like. So negative 28 over 3x minus 4/3 x. Well, that's going to give us this, negative 32 over 3x. I know it's kind of ugly, but let's work with it. And then I'm going to add 8/3, and that's all less than 40. Now let's just solve this as if this was just an equation. I'm going to, actually, there is one thing you could do here. Notice that my denominators on the left-hand side are 3. I could absolutely multiply both sides of this inequality by positive 3 to get rid of those denominators, okay? And I'm just going to do a little note over here. I'm actually not going to go this way, but I'll show you what that does. By multiplying both sides by 3, that leaves us with this, which is super nice numbers to work with. Look how nice those are. But I always find that we often just kind of roll with the punches and kind of go with the fractions. So I'm actually going to solve it that way, but you'll get the same answer. So I'm going to subtract 8/3 from both sides. So I'm left with negative 32 over 3x is less than 112 over 3. I know that's super ugly, okay, but it's still going to work, all right? Okay, the last step here is we are going to divide both sides of the inequality by negative 32 over 3 because that's what's standing in front of the x, right? And we want to eliminate it, so we have to divide by it. When we do that, again, we're dividing fractions, so we can do this right in the calculator. And that's going to give me a solution of x is greater than negative 7 over 2, which is the same as negative 3.5 or 3.5. All right? So, although we have a weird number, that's okay. All right? Let's go ahead and graph it. I'm going to put my 0 there. I'm going to put my negative 7/2, and I'm going to put 7/2. And x is greater than, well, that's going to be an open circle. and it's going to be moving to the right because it's all numbers that are greater than that negative 7.5. My set notation will be x such that x is greater than negative 7 over 2. My interval notation will be parentheses, negative 7 over 2, comma, positive infinity, since it's moving in the positive infinity direction. Okay, so those were two really good examples of multi-step inequalities, and one with a fraction. Now, the last two examples that I want to give you are special case situations that you might run into. And you can see we still have multi-step inequalities here, but we're going to throw some special cases in here. So special situations that could happen when solving an inequality. So let's go ahead and work this first one. Let's begin this problem by distributing like we always do. So negative 6x minus 13 is less than negative 5. I'm distributing negative 6 into my parentheses to give me negative 6x minus 12. Be careful not to subtract negative 5 minus 6. Order of operations says that you can't do that. Now let's go ahead and combine our like terms. So first you look at the left-hand side and ask yourself, can I combine anything? And the answer is no. So the right-hand side, I can. I can combine the negative 5 and the negative 12. So let's go ahead and do that. I'm just going to rewrite this. It's going to give me negative 17 minus 6x. Okay, now let's go ahead and balance our inequality here. I'm going to start with my variables. So I'm going to add 6x to both sides. You're probably noticing something. Notice that the 6x's eliminate from both sides. So that leaves us with negative 13 is less than negative 17. If you get to a situation like this where your x or your variable disappears, then you know you have a special case. And we have to look at this inequality and ask ourselves, is this inequality a true or a false statement? And this one here is false. And the reason that it's false is because negative 13 is not less than negative 17. That is not true. So this is a false statement. If it turns out to be a false statement, that means that you have no solutions. And that is your answer to the problem. Now, if you ask yourself, well, how do I graph a no solution? Well, you can't graph it because there's nothing to graph. So there is no graph. And there's no way to write it in set notation or interval notation because there's no interval to actually represent. And there's no inequality to actually represent. So there's no extra stuff that you can do here. Let's look at the other type of special case here. Let's go ahead and start this next one by distributing. So I'm going to distribute negative 2 in there to give me negative 6x minus 8 is greater than or equal to negative 6x minus 14. And I'm going to go ahead and just continue solving this problem like I normally would. I'm going to add 6x to both sides. And the same situation actually happened here. It was a coincidence that they were both 6's. And now I'm left with negative 8 is greater than or equal to negative 14. I get into that same situation where I have two numbers. My variables have eliminated. But this time, look at the inequality and ask yourself if it's true or false. And this one is actually true because if you think about it, the integer negative 8 is in fact greater than or equal to negative 14. Okay, because it's greater than. All right, and I always get this question. It's a really good question. It's greater than or equal to. So you can see I always get the question, well, it's not equal to. But remember, it's greater than or equal to. And in this sense, it's greater than. So since this is a situation that looks like this, well, our special case answer will be all real numbers. So what that means is that I could substitute any number, any real number into this inequality. And that left side of the inequality will in fact be greater than or equal to the right. It works just like an equation. You just have to focus on now that you're working with inequalities. Now to represent this on a number line, you might be thinking, how do we represent that? Well, I always like to put a reference point on my graph, which is 0. And then I'm going to represent all numbers by drawing an arrow going in both directions. And that represents all real numbers. Set notation will be represented squiggly bracket x such that x exists in the real number system. And then interval notation. Well, look at our graph. Notice how the graph is going in both directions forever. It's first going in the negative infinity direction, and then it's going all the way up into the positive infinity direction. So there is how we represent all real numbers in interval notation. Okay, that brings us to the end of our lesson on 1, 2, and multi-step inequalities.